So this question right here is talking about the rate of change of a spherical balloon. A says, find the rate of change of the volume with respect to radius. So this is dV over dr for A. And so what we have for volume of a balloon, what's that? 4/3 pi r cubed, correct? For the volume of a balloon, a sphere. And so if we're finding the derivative with respect to r, then this is then v prime, or dv over dr. And this is a constant, this is a constant, so 3 comes down in front of those. So it's 3 times 4 over 3 is 4 pi r squared. And then because it's with respect to r here, then if we do the chain rule, r prime is actually just 1. So then when the radius is 0.5 meters, well, then we can plug in 0.5 for r. And so v prime is what? 4 times pi times 0.5 squared, which is what? 0.25, right? Or, I guess, just pi. Does that make sense? The rate of change of the volume. So the rate of change of the volume, did you get pi?
Yep.
Okay, so that is, yeah, the rate of, well, volume would be meters cubed. Meters cubed. And then where's our time, does it say? Okay, I guess it says time in B here. Does it give us the time I'm not seeing? Did it change? Nope. Okay. So meters cubed per probably minute, because we see minute in B. All right. So B now. If the volume of the balloon is increasing at a rate, so we have V prime equals 10 meters cubed per minute. How fast is the radius increasing? So radius increasing is r prime equals, we don't know, when the radius is 3 meters. So this is a related rates. So this is at r equals 3. All right, you see that? So this is related rates problem, and now this is where we're doing dv over dt. Okay, so the preferred variable is time. That's not a variable in there, so with respect to time, means that v, the derivative of v is v prime, the derivative of r is r prime, and any other variable that's in there is just, it's never 1, okay, with respect to time. So if this is the volume formula, so we have v prime equals, now we have 3 times 4 over 3 pi, and we have r squared. This is times r prime now. All right? And so v prime equals, 3 and 3 are gone, that's 4 pi r squared r prime. And we want to solve for r prime, right? Because it says what's the happening to the radius there? How fast is the radius increasing? So this is now divided by 4 pi r squared, and that's gone. And so now we can fill in our values, which we have v prime is 10 over 4 times pi times, and this is at r equals 3, so that's 3 squared. Oops. R prime. Does everyone see that? Does that make sense now for those of you that asked about B? So you just evaluate that, and that should be your rate of change of r. Okay. So is this 10 over 36 pi? 10 over 36 pi, okay, or what's that, 5 over 18 pi. And you can write that as a decimal as well if you wish. Okay, so here's your answer. Sorry, what was your question? Where did I get the v prime? What do you mean? The v prime value, like 10?
No, v prime equals 3.
Oh, this one here? Oh, I took the derivative of the volume formula. Yeah, I just took the derivative over here. See, there's the volume of a sphere. I took the derivative. So 3 comes, oops, let me do that. 3 comes down in front and multiplies by 4/3 pi, right here. And then I subtract 1 from 3 to make it 2. But then chain rule says I have to multiply by the derivative of the inner function, which really the separate inner function is r.
If 3 comes out, then the 3 will cancel the bottom.
Yeah, 3 cancels out with the 3 in the denominator there.
Oh.
So that's why you end up with just 4 pi r squared. Okay,
Thank you.
you're welcome. Anybody else have any questions about this one?